This conference will now be recorded.
So good morning, everyone, and welcome. Thank you for joining us in today's webinar, Data Optimization for Secondary Raw Materials from Mining Waste. My name is Michelle Wagner, and I will be your moderator today. I work in the United Nations University, and alongside my partners, Franz, Katarina, Andre, we would like to welcome you to this webinar. Before starting the presentation, I would like to present a few housekeeping items to cover both the presentations and the GoToMeeting webinar platform. First, we would like to ask you to please mute your microphone by clicking in the microphone button as displayed in this slide. Normally, when you want to speak, you can press it and it will be green. And if you want to mute yourself, you can press it again and it will be red. In doing so, we will avoid having background noise and ensure high quality audio. Moreover, we would like to record this webinar in order to allow participants that couldn't join to have access to it today. And this webinar will be available in Orama's webpage as well as all the presentations. In addition, we'd love to hear from you during today's presentation. So if you have a question for our speakers, please feel free to send it through the chat box at the bottom of your player, and it's illustrated like this, and we'll be answering the questions at the end of the session. If we don't get to your question during today's webinar, we will be sure to follow up afterwards. So please put your email and we will be following afterward. And lastly, we'd like to encourage you to share today's webinar with your social networks. You can use social sharing icons in the Orama website to post this webinar directly on Twitter, Facebook, or LinkedIn. I'd like to kick off by providing you an overview of today's webinar. We will be starting with a small introduction of the Orama project, followed by the webinar per se, and finalizing with a discussion and closing statements. The Orama project focuses on optimizing data collection for primary and secondary raw materials in member states and addresses specific challenges related to data availability, geographical coverage, accessibility, standardization, harmonization, interoperability, quality, and thematic coverage. The project is built on results of past and ongoing projects of which maybe you already have heard, for example, Minerals for You, MICA, Prosum, Panorama, among others. Its main aim is to demonstrate how to create more robust primary and secondary stocks and flows datasets in the EU and make information accessible and compatible with the JRC's raw material information system, which I think you may have heard the RMIS. But how do we create more robust information of stocks and flows? How do we provide recommendations on how to improve data quality and collection processes? As a first step, in the Orama project, we made a structured inventory of data collection practices assessed by data gaps from this inventory. As a second step, we prioritize recommendations, and from these prioritized recommendations, we performed some case studies, which resulted in best practices and training materials, and analyze and create strategies for robust worldwide knowledge based on secondary materials in the urban mine that would be turned into concrete actions in the near future. Now, Now I am pleased to provide to Franz to introduce today's first speaker, which is Franz Schulz. He has a master in geography, geophysics, and computer. I will be providing him the platform right now so that he can provide his presentation. So Franz, you're now the presenter, so you can upload the presentation. And in the meantime, I can say that Franz, he's a geoscientist He's a GIS specialist as well since 1995. He has been working with digital exploration and mineral resources data, both in the Oracle and PostgreSQL databases. He has lately worked with making mineral and energy resources data from Denmark and Greenland available for external use through Greenland Portal, Euro Sources Systems, Minos4U, Eurare, Orama, and many other projects. Today, he will be providing you with an overview of the technical guidelines developed in Orama for mining waste extension to insert data guidelines. So Franz, whenever you're ready, you can start.
Thank you, Michelle. Do you see my screen now?
Yes.
Okay, thank you. And one correction for your good presentation is that I'm a geologist, not a geographist. Sorry. I will present this technical guideline in, I hope, an easy way, so showing how to insert the mining waste data. And you can see all the contributors to this presentation here, all the partners. And now I try to go to the next slide. Orama is optimizing quality of information in raw materials data collection across Europe. And just to show that we are looking at some data and want to optimize how they're presenting. That's the Orama part. And we use this Inspire directive, and we have several knowledge data platforms, ProMine, Minos4U, EURare, and ProSum and Screen. And we also recommend some application developments. This will be taken over by Minos4EU, and especially on how to automate the e-minerals yearbook, so it will also be available through the knowledge data platforms. And we use, of course, Inspire directive and create some APIs, and in the end it will go in EGDI, European Geological Data Infrastructure, and it's all supported by EU Commission, and also will be available through the Raw Materials Information System 2.0. The databases for raw materials in Europe, it's Inspire compliant database, and in the end is a web feature service for each partner. It's developed by Minos4U, Rare, and ProSum. It uses UMLs and database modeling, and we have 60 tables with feature types and data types, 70 tables with code list, and more than 7,000 codes, but about 5,000 is mineral names. The current version is 1.12, and we are trying to update it to a recommended version 2.0. And just a brief on how the core model looks like. As I said before, it was Minos4U and EURare that developed it. Later on, mining waste extension was developed by ProSum. Feature tables are in orange, and data type tables you see in yellow. And just to show where the mining feature occurrence table is, and mineral country table is, and mineral occurrence table, I'll hope it works now. Does not. I have to, yeah, click. You see the mining feature occurrence, and then the mineral producing country table, and last the mineral occurrence table. And another view is on the mining waste extension made by ProSum. Here you see 6 of 13 tables, a green table, and you see the location of the mining feature where it connects to the mining waste table. And yellow is data types, and orange is feature type tables, and the other colors like this and this, they are code lists. And in the guideline, you'll see this figure showing the, as you mentioned before, mineral occurrence here, and ProSum mining activity, and the ProSum mining waste tables. And there's a legend over here telling that the red is feature tables, and then there's some mandatory data type tables as the green, and blue is mine waste extensions mandatory data type tables. It means you have to fill out these tables in order to fill out the ProSum mining waste information data. There's some restrictions, constraints, which are not implemented in the database. It's called exclusive OR. It means the mine table and the ProSum mining activity and ProSum mining waste table, you cannot fill out in mining feature occurrence as one record and referring to these tables. You have, if you want to have a mining feature occurrence to refer to mine and ProSum mining activity and ProSum mining waste, you need to insert 3 records, 3 separate records. That's the meaning of exclusive OR put on. And there's another exclusive OR is between ProSum mining activity and mineral occurrence. There's also an my mineral producing country. And the technical guideline, mining waste extension insert data guideline, is one guideline of a lot of guidelines. First of all, we made the tool stack guideline is on how to start implementing this service. First, you have a guideline defining the recommended tool stack. We use Postgres, PostGIS, and there's some tools on how to install the database. And in order to set up the web feature search, you need some Java and Apache Tomcat and Degree. GeoKettle is used on how to read data from a production database and put it into the Minos4EU database. And Enterprise Architect is, you can see how the database is built up. And then back to the mining waste extension insert data. It's a small guideline, only 26 pages, and has 3 main tables: mine, ProSum mining activity, and ProSum mining waste to insert data in. And you remember it was an exclusive OR on them, so you have to keep that in mind. Just to show the table again, you've seen it before. And I just picked one table, ProSum mining waste. You can see how the attributes is, and also made a reference to the code list used in this table. There's an example of waste type. You have to find the table called waste type. You can look up the codes used for this attribute. And the 4 others is called void reasons type. It's because if you don't have any information of storage type, you need to put up a void reason. You have to explain why you don't have this information. And there's made a recipe on how to fill in the data and which row you should fill in. And Some are short and some are long, but here you have a recipe on how to set in the data. Sorry, this was the wrong way. Waste type table, as mentioned before, has 210 codes, and it's this is a code list, and here you need to find the code to put in the waste type. And this table, you can also look it up in an Excel spreadsheet. Maybe it's easier to read more about the codes there, or what the meaning, and you can look it up. Some you can look up on URL as well. And as a summary, setting up the whole system, you need to use the toolstack guidelines and use the mining waste extension on how to insert the data. You need some DB knowledge and some IT, or you'll get it through reading all the guidelines. The code list you can look up either in the database tables or in a spreadsheet. You need in your organization a mineral expert for quality control and also quality assurance of your data, and some support from the IT to keep this web feature system up and running. And here are some links and downloads where you can find all these guidelines, and for later on you can download it yourself. Thank you.
Thank you, Franz, for your excellent presentation. And we will have the questions until the end. So now I am pleased to introduce today's second speaker. I will be making you the presenter, Katarina. Katarina Riebrink, she has a master's in information systems and is experienced in database specialist, working 20 years in GIS, Department of Geological Survey of Slovenia. Lately, she has been working in many projects, including the Inspire Directive, like Eurogeo Service System, Minerals for You, Prosum, Orama, Reserve, and among others. We can see your presentation.
Yes.
Can you put your presentation in the screen?
Yes, just a minute, please.
Yes.
Just a minute.
Today, she will provide you with an example of national data sets, harmonization of primary and secondary raw materials information with Inspire compliant protocols using Slovenia as an example. So, so we will just wait a little bit for her to put the presentation. There you go. And
Yes.
Please continue, Katarina.
Yes, thank you, Michelle. I will show you an example how to map data into database. Franz has already represented guidelines, and I will show you an exact case how to map the data into tables. The reference file formatting is this mining wake station insert data guidelines, and when mapping, someone who maps need to have these data models and these documentations. Those are models Miner for Europe, EU, and then data models of Prosum database listed here. And from these data models, we can see relations between tables and also obligatory data, which are marked with little star, data types, and so on. For proper mapping, you also need some code lists that are listed here. And when using code lists, it's very important to use a first column from the code list, not another columns like names, description, and so on. And it's also obligatory to enter mandatory data, which are marked with little star in tables. And also all those files are available on this Timery site. Here you can see list of tables which have to be filled to complete your information. There is two types of tables, obligatory tables and some other improving information tables, which are also very important. And we also took into consideration Slovenian data availability. So tables that we have to enter are, first we have to enter mining feature occurrence table, which is mandatory table with geometry inside, so we have to fill it. And then we fill the table mine, which is also mandatory data type table, because every waste location is connected to some mine. Then we have to fill a Prosu mining activity table, which is also mandatory table. And then connected to Prosu mining activity, there's a table Prosu mining activity type, which is improving information data table. Then another mandatory table is Prosu mining quest table. And there are also three other tables, improving information data type tables, like environmental impact, Prosu mining quest measure, and Prosu mining quest dimension. Other important things to know while mapping are listed here. Very important is Inspire ID. This is a global unique identifier, which uniquely identifies a spatial object. And in Slovenian case, we use first the abbreviation of table. And when we enter the data in mining feature occurrence table, we use the abbreviation MFO and then number 1, 2, etc. Like you see, you see an example in below in table. Then very important are also the columns with postfix DBK, which is a unique database key without any meaning, and those are normal numbers from 1 to eternity. Also in database there are columns, void reason counts, which can be either left blank when information is known, but when we do not know the information, we have to fill the void reason column and fill it with those three values, unknown, withheld, or unpopulated, from the void reason type code list. And this is obligatory. So as you can see, the mining feature occurrence table, which is the first table which has to be filled, we have to enter following attributes: Inspire ID. Inspire ID, as I already said, is abbreviation of table and then numbers from 1 to eternity. Then another important field is Inspire NS. In Slovenia, we used the abbreviation of country, SC, and then we put also abbreviation of our geological survey. And of course, the last field is Inspire version ID, which is 1 in our case, because this is our first version, and in the future when we will change data, we will change this number to 2, 3, or so on. Then in the last column, you see Inspire version void reason. This field is in this case blank, because we have all three fields filled. So there is nothing. So once again, a separate mining feature occurrence of each individual mine, processing plant or mining quest must be created first before another tables. Also, another important things are XORs, but this was explained by friends before, so I wouldn't go to details here. Now we will show how to insert data first in mine table, then Proso mining activity table and Proso mining quest tables, which are obligatory tables. So before insert a row in mining table, we have to insert a row in mining feature occurrence because there is a geometry. And here on the right, you can see columns in table mining feature occurrence, and also those little stars, which means obligatory fields. So here you can see our example of mine in table mining feature occurrence. We have only one mine connected to mining quest, so we put here one mine. We put inspire ID like I said before, MFO01, and then our version is 1, inspire NS is SCGO as the sub, and void reason is blank because those fields are filled. And then this is also obligatory field, geometry is also obligatory field, and it is a transformation from your local coordinates. So when we have entered a row into mining feature occurrence, we go to table mine. It is the same. Here are columns of table with obligatory fields, and also here you can see matching code lists. Code lists, those are columns, and then matching code lists you have to use. And some recipes how to insert data in table mine. First, it's a little bit small, but first we enter mine DBK. This is unique identifier for mine. Then we enter mining feature occurrence from previous table. We have to use the same DBK. Then we enter begin lifespan version. That means when this mine was entered in database. And then void reason is empty because we have this field entered. But since this lifespan version has not ended yet, we leave this blank. But in this case, because this field is blank, we have to fill void reason with unpopulated. Then we enter a name of mine, in our case Mezica, and status is closed. Those are obligatory fields. You can see here mine status is obligatory, and also name is obligatory because there is a little star. And then also country. Field country is obligatory. Other fields are filled with void reasons and populated. Then let's go. So it's Proso mining activity table, and it also has to be entered first in mining feature occurrence table. So let's go back, and we must fill mining feature occurrence table. And since in Slovenia we have 4 Proso mining activities, 4 mining quest locations, we just add to this first number, we add just 4 another mining quest, 2, 3, 4, and 5. And we also enter inspire ID, inspire version ID, inspire NS, which is always the same, and geometry of these Proso mining activities. And then we insert a row in process mining activity. The procedure is the same like before. Here are columns with obligatory fields. Here are relations to code lists and some recipes. And we enter this table with obligatory fields. And also we enter begin time, end time, or processed. We don't have or processed, so we filled void reason type, etc. Then we also insert the process mining activity type. The same way using code list for mining activity type, you can see here our four mining activity types for four waste locations. And then we enter a row in process mining quest. And also before we have to fill mining feature occurrence table again, so we add another 4 mining feature occurrences and another 4 geometries. So this first is our primary mine, which has his own geometry. Then we have 4 mining activities with 4 different geometries, because it has to be like that. And then we have 4 mining quest locations with 4 another geometries. And then we can enter a row in process mining quest tables. So we use those WCUS and from previous tables because it's a relational database. And then we fill obligatory row waste type from this code list waste type, and other fields are unpopulated because we don't have data. Then this is not obligatory table, but it's good to enter this data, and we use those WCUS from previous tables, and we use environmental impact for this location from the code list environmental impact type. And then we have a table process mining waste measure, which is also not obligatory, but improving information table. And we entered this table using those code lists and using those WCUS from previous tables. And in the same way, we insert a row in process waste dimension. We fill max area, we enter unit of measurement and maximum volume, and that's it. What are most recognized mistakes while entering? We don't use proper IDs. They are not compatible. We have to be very careful because those IDs or WCUS are very important, and we have to connect correct mine to correct waste and so on. Then some obligatory data are missing. We have to fill all the fields marked with star, and also code lists are not followed. We have to enter the first column, as I already said, and then wrong data types are entered, and we have to also fill tables in correct sequence because there are relations between them. XORs are not followed, and void reason fields are not entered. So when we enter all this data, the harmonized database is established, and data is prepared to the harvesting. And this will be next presentation from my colleague Andrei. Those are references, and thanks for your attention. I hoped it wasn't like this and you haven't slept. Thank you very much.
Thank you, Katarina, for your lovely presentation. Are you next to Andrei?
Yes, we are here.
Okay, perfect. So Andrei Vitalich, he's an expert in object programming, relation databases, and use of open source solution in nonlinear and time-dependent numerical analysis. He has a master in civil engineer and he has experience that covers working at Hewlett-Packard Center, employed at SoftLab, and from 2013 he's participating in PRAISE, which is the Partnership for Advanced Computing in Europe project field of parallel programming and numeric simulations of physical processes of HPC. And he is currently working employed at GeoSet, Geological Survey of Slovenia, responsible for minerals for EU and Prosum harvest systems, and also is the head of application infrastructure in GeoSet, Geological Information Center. So
yes,
I'll,
we have a little problems with mouse, so
yes, no problem.
yes, we can't. Okay, okay.
Hello
Yeah,
to
and
everybody. I would like to present the basic of the harvesting system for collecting and validating mineral resource data. We will go to the basic principles and standards used in harvesting system program for the collecting and validating the mineral data. The program was developed at GeoZC, Geological Survey of Slovenia, and improves, extends, and disseminates the European geological data infrastructure and provides access to pan-European and national geological databases and services from the Geological Survey organizations of Europe. The program, despite many challenges, is considered as an important part of the application infrastructure in Europe. Well, first, what harvesting is. Data harvesting is a process which reads and automatically extracts large amount of data from the web. That is from web pages, or in our case, from web services. And I would like to emphasize that harvesting is not a data mining, but the collecting of data from web services. We know that in reality, a country has its own specific way to describe the nature, and the nature does not enter the borders. So data must be compatible to the borders. And so we need the Inspire solution which provides us a common standard for phenomenal description, for information exchange, that means online services. Scientists often store data in Excel fields, but for serious work, data must be structured and stored in relational database, because SQL language made automatic data processing possible. To introduce web services, we must say that the basic of web communication is HTTP protocol, that is Hypertext Transfer Protocol, which is initially designed for communications person with a machine. We are all familiar with these standards because we are all browsing web pages, and this protocol is used. But for web services, this protocol has been extended and developed for communication machine with machine. And we need the machine readable formats which contain data like XML, GML, and JSON format. And that means that one machine gets a request and other machine responds to these services. Here we have some example of the service results. It's ordinary web page, but with different content. There are such structures of the data. And here we can see the basic architecture of the harvesting system. which we have to divide on two sides. On left side, you see a country level. On the right side, you see European level provided by Geological Survey of Slovenia. On left side, each lines denote some provider. For example, we have here 5 lines. That means only 5 countries are presented here. And each country usually has his local, his data stored in local database, and use a GeoCattle to transform the data to Inspire compatible database. And on this database, they run services. We have services with degree service to provide the services on their data in database. In European level, we at GeoCC running a harvesting program to give a request to all provider services and to collect, validating and storing the data in Central EU Geological Database. The program is developed in Java, object-oriented with object-oriented programming, so when it's parallel computing. Just a few words about oriented programming. Object-oriented programming is a program model based on concepts of objects and interaction between objects and messages. And on the right, you have just the main keywords of the object-oriented programming, but existence are okay. Here you can see the standards and technologies used in harvesting program. And example of country data display after harvesting is provided. And the Franz and Katerina and me, I will also say what the provider has to watch out. First, most important is stability of identifiers. As you know, each record has his Inspire identifier, and the identifier for the same data must stay the same for all the time. The problem is that provider usually deletes their own database before fill it again, and if there is no care about the identifiers, we cannot compare the data between different harvesting. The important is also the accurate of data entry and that our data up to date, not only wants to satisfy the project requirements. We want to have live and true data on that, so we need accurate data and accurate updating the data from the providers. And also we like that all providers fill all the data that they have, and that we don't have errors at the harvesting. The most important is also compliance with the XOR. Okay, here is just after harvesting. We do some overview of the data harvesting. We harvest a little more than 1 million records of data at each harvesting. On the left column, there are the table names which are harvested, and on the other columns are the countries with the number of the records harvested in from some tables. But this example is not accurate. It's not the current state, but just an example. Well, we all know that our Minerals for You database has more than 50 tables. So if there are any data this data will be harvested and then will be shown in that table. So currently only approximately 15 tables are filled in, and so only 50 tables were harvested. Well, we talk a lot about this XOR correlations and requirements, and I'd like just to mention that it's not a logical XOR and means mandatory connection to or from only one table. And this is currently not checked with double constraints, so the providers can write the wrong data in their database and will not be informed about that. But the harvesting is checked by the XOR correlation is checked by harvesting, and in non-compliance they leads to data harvesting error. And what's the infrastructure for data providers? Well, first server with internet connections, and all other things can be found on cookbooks, software, and scripts, which are provided on Geo's GitLab server, on the rest marked on the screen. Then, of course, providers need to their logical data to fill provider Inspire compatible database, and this is the most difficult part because their national database must be compliant with must be transferred to Inspire compliant geological data here, and there's the regular care of data and updating by providing stable Inspire ID, and system maintenance is also required. And here you can see just the projects where Geological Survey of Slovenia use harvesting system. And that's all, and thank you for your attention. Hello?
Yes, thank you, Andrei, for your excellent presentation, and also Franz and Katarina. Thank you so much. We will go ahead and take some time for questions now. Just a reminder, please be sure to type your question into the question box in your control panel. As well, if you have comments, we would love to hear from you. So I will take a look at the.
I think there this geometry question.
It's from Carlos Cormio, and it's I think it was during your presentation, Katarina, about regarding geometry has to provide in WKT format.
Yeah, good morning. It's Carlo. I was wondering if the geometry field had to be provided in a specific format, well-known text, well-known binary, or in which way, from a practical point of view, it can be introduced that information about the geometry. So is it, first of all, is it considered to be a polygon? Is it a point or what else?
No, your local, for example, ETRS coordinates or WGS, there are certain SQL sentences to transfer this to geometry.
Okay.
For all geometry, points, line, polyline, and multi-polygons is used PostGIS. So
this goes automatically.
Yeah. Okay. Thank you.
Because countries give us local coordinates, and we transform this into this binary binary form.
Okay. And what about?
Maybe Andrei can explain.
The coordinates must be in this Inspire compatible database of the provider and in PostGIS format, and we just read this data and write it in our harvesting database. And it must be in specific format, but I don't know it because I'm not a geographer. We are looking for it, and maybe we will find it in 4258. In format 4258, but
Just a moment, we will try to contact our colleague, which he's dealing with this. So he will come and he will tell you. Just a moment.
In the meantime, Katarina, perhaps we could answer Aldo Femias.
Okay. Okay. Which one I have to answer?
Aldo Femia would like to know an example of typical.
Okay. Yes.
May I ask the question?
okay,
Yes, please.
Andrei is here with coordinates.
The format must be in APSG 4258.
Do you know what it is? I'm not.
This is a kind of projection.
Thank you. Perhaps we can provide Aldo then the.
Maybe Andrei could write this here for people to see. To write an answer for coordinates. The system itself does not convert. Ai proiecție to, Mattia.
Yeah, okay, thank you.
Yes, it's a projection.
Yeah,
Do you understand?
so coordinate projection, yes, okay.
Just a moment, Andrei will write. Okay.
Okay,
Yes.
thank you.
Thank you, Katarina. Now we will proceed with Aldo.
May I speak? Do you hear me?
Yes, we can hear you.
Okay.
Yes, I can hear.
I'm sorry I could join the webinar quite late, so I might have missed something. So excuse me if I ask something that has been said before. I'd be particularly interested in knowing what a typical data source of this harvesting is, and what the units of analysis are, to which units are the data refers. Thanks.
It was very bad voice connection, so we cannot hear you. Can you repeat, please? All right.
Okay, I'll speak slow.
From what I could hear and from what I read in the chat, he's interested of what is the typical data source.
For what?
What do you mean with this typical data source?
Yeah.
Aldo, would you mind writing what do you mean with the typical?
A typical data source for our data, for Slovenian data.
He wishes to have like an example of what would be a typical data source. Does it vary from country to country?
Yes, of course. Data sources are, each country has own data sources. We collect data from reports, from field trips, and we also have our local databases, so we transfer data into this harvesting system. Yes.
And what would be the unit of analysis?
Unit of
analysis
which analysis?
of the data source.
Maybe I can answer that question.
Yes, please go ahead, Franz.
In the MinOS4EU database model, there's I think 8 or 9 tables with units, different kind of units. You have point, you have lengths, and you have areas, and you have a measurement unit like
Yes.
grams and tons and kilos and so on. There's codeless tables for this.
Yes, and there are also code lists from this unit of measurements, for example. You have to use code lists for data sources.
Thank you, Katarina and Franz. Does anyone else have any questions?
I have one more. It's Carlo Cormier again. Did you already took into account the option for, let's say, massive, I would say it's not right, but let's say massive upload of data from existing local databases, or this is something that will be addressed by national authorities, let's say the local geological surveys? Because of course there are hundreds or thousands of sites and millions of information to be transferred into the new information system. So I think you don't mind about inserting this data site by site. So did you address this topic? Do you have guidelines for this, or this is something that has to be managed by local authorities?
We have guidelines for everything, for inserting data in database minerals for EU and ProSum database. And each country, every local provider has to map data to this database at their own institutions.
Thank you.
Is it okay? Or maybe Franz can answer, can add something?
Yes, at the moment there's 23 partners in Europe providing data through the MinOS4EU database, and we encourage more countries to join in. And this guideline for ToolStack shows how to set up the whole system, and then we provide also how to insert data in the database. So if a data provider has a local production database, this guideline shows how to install a new database on a server, and then you transfer those data you want to provide through the INSPIRE directive provided for whole Europe. That's the idea in this building up the MinOS4EU database.
Thank you, Franz. Thank you, Catalina. Mr. Aldo Femia would like to know regarding the units to which the data are referred to, countries and enterprises, local units, if you have further information.
No, me no, I don't know, really. I don't understand this question, really. Local, I don't
The
know.
units to which the data are referred to.
Aha.
For
Like
countries.
administrative units. Or what?
Could you repeat again?
Administrative units or
Okay.
something like that. Or like spatial units or
well, would you like to speak, Aldo, so that you can provide further?
Yes. What? Yeah.
I can try, but the connection seems to be a bit weak.
Yes, connection. We really bad connection. Yes.
Okay. What I wanted to know is about the typical source in the harvesting. That is, what do you look for in the web? What would be an appropriate source for you in the harvesting of the data? And in the database, which are the units to which the data are referred? I got an answer on this. It is spatial units or administrative units, as far as I could understand. Thank you.
Do you mean administrative unit? Because we have, for example, we have concessionaires which have those mines, and this is another data model. It's management zone data model, which is not included here, but it's another Inspire group. It's management zone data model, if you mean something like that. And we have concessionaires for those mines, and we put also this in this database.
Okay, thank you,
Can
Katarina.
I don't understand really. Maybe an example.
I make an answer? Try.
Yes.
Okay, Aldo, what we are looking for is a registration of mineral occurrences, mines, and commodities. In order to show the Commission that where do we have all the different kind of occurrences with a specific commodity. That should be answered through the portal at the end, and it will be on EDGI portal at the end. So is that what you're asking for? What type of data we put in this database?
Well, Aldo said that thank you for the reply, and unfortunately we are out of time. It's 12 o'clock, but if you have further questions, you can contact us. I wish to thank everyone. We appreciate you being here, and we wish to thank everyone for joining. If you want to have more information regarding the contents of these presentations or more information on the material, you can reach us through our website. All presentations, webinar recording, protocol guidelines, and further information can be found in our websites. In addition, we will have the final event in Brussels, so you are all welcome to join us. And the further results of the project will be provided and presented. In addition, we will be also presenting some findings for waste electronic equipments and PV panels and batteries and ELV during the WE Expo. So if you're also interested, you can come and join us. We will be also holding some further webinars on the 2nd of October regarding primary materials, on the 16th of October regarding batteries and ELVs, and on the 17th of October we will be holding for WE and PV panels. So you are also joined to register to the webinars and join us. And we wish to thank everyone, and we would like to ask you to provide us with some feedback, comments regarding the webinars, and therefore we have also created a Google form so you can provide your input. So we wish to thank everyone on behalf of, well, Katarina and Franz and Andre. I don't know if you want to include something further.
No, it's okay.
Oh, fine.
Okay, so, well, thank you everyone, and Looking forward for hearing from you. And please remember to log into our website, and you can find all the materials there. Thank you, everyone. Bye. Have a nice day.
Thank you, Michelle. Bye-bye.
Thank you. Bye.
Bye-bye.
Thank you.
Bye-bye.
Bye.
Widzę, że to